Hello, this is a video review of Unit F Quiz 1, which is focusing on conversions using the mole. So this first question is this entire first graphic organizer, and all aspects of this question are related to the molecule of carbon monoxide. So there are 5 blanks. There's this blank that is the middle step between converting particles and mass of any material. So before you can convert between particles and mass, you need to understand that the mole is the unit that is the conversion between those two different variables. So if you're trying to convert mole into particles, you need to use this number called Avogadro's number. And it doesn't matter what particle you're talking about, that is always the number. But for this example, we're talking about carbon monoxide, so that would be the chemical formula. Both of those atoms, carbon and oxygen, are both nonmetals. That means that this is a covalent compound. So of the 3 types of particles, they could be atoms or molecules or formula units. Because these are covalent compounds, the name of this type of particle is a molecule because it's a covalent compound. So these should be listed as molecules. There's 6.022 times 10 to the 23rd molecules are equal to 1 mole. Now separately, if you are trying to convert moles into mass, you need to use the periodic table. So that's the tool that is required to make any conversion between the units of moles and the units of mass, which is like almost always going to be grams. So for this class, it will always be grams. So if you are looking for the conversion factor between moles and grams, you have to say that 1 mole is equal to, and you need the individual mass of each separate atom. So carbon has a mass of 12.01, and oxygen has a mass of 16.00. So in total, if these 2 individual atoms make up 1 compound, the mass of 1 mole of this compound is going to be 28.01 grams, because this number at the top where I did the calculation is called the molar mass. This is the number of grams per mole. So if you are looking for a conversion between grams and moles, you can set 1 mole equal to 28.01 grams. So this is the type of information that you need to be able to do no matter what this compound is. So if this example is carbon monoxide, these are the things that are going to be different. If you use a different chemical like water or methane or sodium chloride, then the name of the particle might be different, and most likely the molar mass will be different. But regardless of what type of matter you're talking about, these are the examples. This is the example for carbon monoxide. Okay, moving on after that graphic organizer, it asks you to complete these problems. And these are all conversion problems, which means they basically are just dimensional analysis. So there are 3 steps to dimensional analysis. This question asks you to convert moles into atoms. The question is, how many atoms? So whenever you do dimensional analysis problems, the very first step is to identify the pathway. Once you have your pathway, then you need an equality that sets those 2 things equal to each other. So how many moles equal how many atoms? Well, the conversion between moles and atoms is Avogadro's number, which we set up here. A mole to any type of particle is going to be that giant number, Avogadro's number, 6.022 times 10 to the 23rd. So 6.022 times 10 to the 23rd atoms. Now, the third step of any dimensional analysis problem is to set up the multiplication so that the units will cancel. So if you have 0.125 moles, you have to set it up in a way where moles is in the numerator of the first number, so that moles should be in this denominator of the second number. That means that Avogadro's number, that giant number of atoms, goes in the numerator of your conversion factor. And here you can demonstrate that the units of moles will cancel. So after you do this setup, then you can use your calculator to set the number 0.125 times 6.022 times 10 to the 23rd, so that the number that is written in the number that the calculator displays is 7.5275 times 10 to the 22nd. Now, your number that you started with has 3 significant figures, so you have to look at the third significant figure and round it based on the number that comes after. So even though the number from your calculator is 7.5275 times 10 to the 22nd, the correct answer for a problem like this would be 7.53 times 10 to the 22nd, and then units must be included, so you need to list atoms. Question 3 asks you to convert moles of oxygen. Well, it starts with molecules. And sometimes these questions are written in a way that is a little bit backwards, but it gives you this many molecules and it asks for how many moles. So any type of conversion problem has 3 steps. This question is asking for the pathway. So molecules, 2 moles, that's the pathway. Now that you have your pathway, you need a conversion factor. So to change molecules 2 moles, if you have 1 mole, that's Avogadro's number of molecules. 1 mole of anything is this many of them. After you have set up your conversion factor, the third step of any dimensional analysis problem is to set up the multiplication so that the units will cancel. So we have a number with 4 significant figures, 1.725 times 10 to the 22nd. Molecules. It's important to use units so that you can show that they cancel. So since we want molecules to cancel, Avogadro's number of molecules should go in the denominator, and we're going to be left with moles. So 1.725 times 10 to the 22nd divided by, now a lot of people who make mistakes in this are going to make mistakes on problems like this setup. If you have a number in scientific notation in the denominator and you do not use parentheses, your computer does not understand the correct order of operations. So be sure you use parentheses for numbers like this, so that if you type it in correctly on your calculator, 1.725 times 10 to the 22nd divided by 6.022 times 10 to the 23rd would give you a number that looks like this, 0.028644968. Now, obviously, you're not going to use this whole number. The number from the problem has 4 significant figures, 1, 2, 3, 4. So we have to round the 4th significant figure based on the number that comes after. So our final answer would be 0.02864, and then the only units that remain are moles. The other possible way of writing it is, because this is kind of a small number, you could use scientific notation, 2.864 times 10 to the negative 2nd moles. Both of those would be acceptable answers. Okay, the next couple questions asks you to convert grams and moles. So this is the other side of the conversion, are grams and moles. So question 4 asks you to go from grams, if you have this many grams, how many moles do you have? So that's the pathway. We're trying to convert grams into moles. For problems like this, where you have an equality between grams and moles, you need the number from the periodic table. So if you don't have a periodic table handy, I can tell you that the molar mass of carbon is 63.55 grams of copper are equal to 1 mole. So after you have the conversion factor, the third step of any dimensional analysis problem is to set up the multiplication so that the units will cancel. And since we have grams in the numerator of the first problem, the grams are going to have to go in the denominator. That means you're going to divide. 63.55 grams goes in the denominator. 1 mole is in the top, so 12.7 divided by 63.55. It's going to give you an answer of 0.199842643. That's what would show up on the calculator, but depending on the fact that we have only 3 significant figures, we have to look at the third significant figure and round based on the number after that. So that 0.199 with an 8 will cause this final value to round up to 0.200. And then because grams end up canceling, you must include the units of moles. So it's also good to include what chemical you're talking about. So in this case, it is moles of copper. So 0.200. And you need these because these digits are significant. So 0.200 moles of copper. The next question is the other direction. It gives you moles and asks for mass, and the units for mass are grams. So you're trying to go from moles into grams. And so you need an equality of moles of a substance into grams of chlorine gas. And this one is diatomic, so many people didn't realize that a molecule of chlorine is different than an atom of chlorine, or maybe you didn't remember that chlorine is diatomic, but it is. Bro, I have no freaking clue is the Cl. So 1 mole of chlorine gas is, so chlorine by itself is 35.45, but if you have 2 of them, the mass of 1 mole of chlorine gas molecules would be 70.90 grams. So if you were to set up this problem, 0.625 moles of chlorine, put it over 1, you want 1 mole on the bottom, and you have 70.90 grams. So if you set it up this way, you can demonstrate that the units of moles will cancel. So 70.9 times 0.625 is 44.3125. Our number starts with 3 significant figures, so our final answer should round based on the number after that. So that means that the final mass of 0.65 moles would be 44.3 grams of chlorine. All right, the last regular credit question on the quiz asks you for number of atoms of a certain mass. So this is giving you, so the first step of this problem is it gives you mass. So it is asking you to go from grams into atoms, but you can't go straight from mass to particles. There is a step in the middle, and it is the mole. So you've got to go grams to moles and then moles to atoms. So you need these 2 separate conversions. So how many grams of calcium are equal to a mole of calcium? So 1 mole, and because we're just talking about calcium, that's only 1 element. That makes it easy from the periodic table. All you need to do is look up and see that 40.08 grams of calcium is equal to 1 mole. And then because it's an element, 1 mole is going to be equal to a certain number of atoms. That's the particle of an element. So the smallest representative particle of an element, like calcium, would be called atoms. And so that's Avogadro's number. Okay, so you have those 2 equalities. Now, thirdly, you've got 24.75 grams of calcium. Put that over 1. And now we're going to use these 2 separate conversion factors to set up the units so that they cancel. So since we have those 2 steps, we're going to need both of these conversion factors. But since we're starting with grams, the top one is the one that's going to have to show that the grams cancel. So 1 mole will go on top and 40.08 grams will go on the bottom. And after we have converted to eliminate grams, now we need to eliminate moles. So 6.022 times 10 to the 23rd atoms is going to go above 1 mole. And so now we have the problem set up in a way where the grams cancel and then moles cancel, and so that the only units that remain at the end are atoms. So if you use your calculator to say 24.75 times 6.022 times 10 to the 23rd, and then you're going to divide by 40.08, would give you a number of 3.718675 times 10 to the 23rd, but recognize that there are 4 significant figures in your problem to begin with, so you need to write an answer that has only 4 significant figures. So 3719 times 10 to the 23rd atoms. That's the final answer for question number 6. Okay, and that does it for all the regular credit questions. But the final question was extra credit, and it asks you if you have a certain volume of water, how many atoms would there be? So really the pathway would be volume of water all the way to atoms, but we don't have a conversion straight from volume to atoms, so you can't do that. But if you know the density of water, which we do, water has a density of 1 gram per milliliter. You can go from volume to mass, which is measured in grams. So volume is measured in milliliters. Mass is measured in grams. And then you can go to moles. And then you can go to atoms. So this is actually a 3-step problem. And if you have 25 milliliters, we need an equality of milliliters to grams. So here are your 3 separate equalities. So how many milliliters are equal to how many grams? And since water has a density of 1 gram is equal to 1 milliliter. Then you're in grams, and you need a conversion between grams and moles. And for water, there are 18.02 grams are equal to 1 mole. And the third step are moles to atoms, and this is the same as any conversion we've done so far. If you have 1 mole, you got to get to representative particles. And even this one, I missed the step here. You can't go straight from mass to moles to atoms. We have to get to molecules. So water is a compound. So 1 mole is 6.022 times 10 to the 23rd molecules. But the question is, how many atoms are there? And in a molecule of water, so in 1 molecule of water, there are 3 atoms. Okay, so I lied before. This is actually 4-step conversion. To get all the way from volume into atoms, you need volume to grams, grams to moles, moles to molecules, and then molecules to atoms. So we could set this up so that you start with 25 milliliters. And then the first steps are pretty easy. 1 gram is equal to 1 milliliter. And at this point, we get from grams into moles. And then from here, you have 1 mole, which is 6.022 times 10 to the 23rd molecules. And then specifically for water, in 1 molecule of water, you have 3 atoms. So here are the setups. So if you use your calculator, you will go 25 times 6.022 times 10 to the 23rd times 3, and then all of that is going to be divided by 18.02 times 1 times 1 times 1. So the final answer of how many atoms are in 25 milliliters is 2.506 times 10 to the 24th atoms. And of all of those atoms, 2/3 of them are hydrogen, and 1/3 of them would be oxygen. That's it. If you have any questions about this quiz, feel free to contact me. Good luck preparing for your test.